Hello everyone, welcome to Concepts in Chemistry YouTube channel. So today in this video we are going to discuss very important and conceptual questions from carbohydrate chemistry. So this is chemistry concept booster question number 27, and this will be the most conceptual and also it is a very important questions regarding upcoming competitive exam. So let's see the questions. So this is the question. If we treat D-glucose by this series of reagents, then what will be the product? So I just want to give you some information that regarding these questions, that in GATE 2020 same questions पूछा गया था, not these questions, just using D-glucose treating with acetone excess in acidic medium. So in 2020 see the questions, this was the questions जो 2020 में गेट 2020 में पूछा गया था, डी ग्लूकोज एसीटोन एक्सेस H plus. So now we modify the questions. So this type questions कभी भी, since just using D glucose in presence of acetone in acidic medium, what will be the product? This type of questions पहले पूछा गया था. Now we added some more reagents to see what kind of mechanism takes place, and yeah, by these reactions, you guys, I am telling you that lots of concepts you will learn from only these questions. So let's start. So गेट 2020 में जो क्वेश्चन पूछा गया था वो था सिर्फ डी ग्लूकोज एसीटोन H plus. Yeah, we set same questions using two more reagents. So let's see. One point that I want to mention you before starting, that these questions we already discussed separately. So the whole discussions you will find in a separate video. So I think you will find somewhere I button, you can click and see the videos. So we already discussed detail about these questions. Now just I wanted to give you some recapitulations of that previous video. So let's start. So this is the glucose, D-glucose, you all know. This is the series of reagents. First acetone excess H plus, sodium hydride benzene, CH2 methyl iodide, then N-butyl stanium hydride and AIBN, at last aqueous HCl. These are the options. So let's see the actual things. So again I am telling you that the detailed discussions, हम लोग ये वाला वीडियो में डिटेल डिस्कशन नहीं करेंगे. जो पहला वाला जो क्वेश्चन था गेट, ये क्वेश्चंस डिटेल डिस्कशन हम लोग एक प्रीवियस वीडियो में पहले कर चुका है. सो प्लीज सी द वीडियो, so you will understand then what is the chemistry behind these reactions. So just थोड़ा हम लोग डिस्कस कर लेते हैं प्रीवियस वीडियो में, जो डिटेल डिस्कशन हम लोग कर चुके हैं उसका थोड़ा जस्ट फॉर रिकैपिचुलेशन. सो लेट्स स्टार्ट. So this is D-glucose. So D-glucose is a hexose, we all know. D means the bottommost. There are 6 carbon, 1 2 3 4 5 6, 4 carbon are chiral. So D means the bottommost chiral carbon. This one, the bottommost chiral carbon, that configuration should be D, means the OH should be right side. That's why D-glucose. So this is the acyclic form of glucose or D-glucose. These are the cyclic form of D-glucose. These are 6-member cyclic form including this oxygen. This is not a CH2 group. Just for simple drawing in a Pran structure, we just draw like that. Please keep in mind that this is not a atom in member, means this is not a CH2 group. So carbon 1, 2, 3, 4, 5 and oxygen 6. This is not any CH2 group. This is not CH2 group. So for just our drawing purpose, we draw like that. 1 point, this is D-glucose. So we can draw D-glucose in a simple form like that. Again drawing OH and hydrogen, CHO, CH2OH, we can draw like a simple form like that. The round head indicates CHO and this line indicates the OH group. See, right side OH group, left side OH group, this line indicates OH group, and then 2 OH group, this line, and the tail indicate the CH2OH group. So again and again, instead of writing this structure, we can write a simple structure like that. So yeah, now let's start the main point. So we all know that in nature all the carbohydrate like glucose, fructose, they all exist maximum portion, means more than 99% in cyclic form. These are the cyclic form, we all know. This is 6-member cyclic form, these are 5-member cyclic form. So the D-glucose exists more than 99.8% in this glucopyranoside form. 6-member cyclic ring called as glucopyranoside, glucopyranose. Alpha D GP means alpha D glucopyranose, beta D GP means beta D glucopyranose. We all know the anomer, these are the two anomer. If OH is right side, then we can call as alpha anomer. If OH is left side, then we can call as beta anomer. So we all know that beta anomer is more stable than alpha anomer. So we all know if we draw the cyclohexane chemistry, then this OH group should be in equatorial positions. That's why in this case beta anomer is more stable. So in equilibrium concentrations, the proportion of beta anomer is maximum, means 64%, and alpha anomer 35 point something. Now this D-glucose also exists in a 5-member cyclic form, that are called alpha D glucofuranose. These are alpha D glucopyranose 6-member ring, these are furanose 5-member ring. Since oxygen is in the ring, that's why it's called furanose or pyranose. Again here, see, this is carbon 1, carbon 2, carbon 3, carbon 4, oxygen 5. Please keep in mind that this is not any member of ring, this is not any CH2 group. For our drawing purpose, we just draw like that. So yeah, till now we learned that glucose, D-glucose, or naturally all the glucose are D in nature. So in nature glucose exists in D form. So natural glucose is in D in nature. So it exists almost more than 99% in cyclic form and some amount of acyclic form. Now more than 99% exists in pyranose form. Less than 1% or less than 1% mean more than less than 1% exists in furanose form. I think you all understood till now, till this point. So cyclic form pyranose, 6-member cyclic form, 5-member cyclic form furanose. Now come to the main point. So these are the different pyranose form in 6-member. I draw here. Beta form, OH equatorial positions, we can draw like this also, and these are the furanose form, we can draw like this. This is alpha D glucofuranose, this is beta D glucofuranose. This is the pyranose form 6-member ring, this is the furanose form 5-member ring. This is alpha beta alpha beta. So now come to the main point. When we treat it with glucose in presence of excess acetone H plus, what will be the product? So we all can imagine that this glucose react via this 6-member ring, and acetone, I think we all know, or many of you already know, that acetone we can use for protection of hydroxyl group. Which type of hydroxyl group? 1,2-diol. We all know another point, that if there is presence of 1,3-diol in cis manner, then we can use benzaldehyde for protection. So if there is 1,2-diol in cis manner, then we have to use acetone for that 1,2-diol protections. Acetone react with 1,2-diol to protect that dihydroxyl group. And if there is present 1,3-diol, means 2 hydroxyl group in 1,3 positions, then we have to use benzaldehyde, non-acetone. Now the reaction is that we all know, if there are many hydroxyl group in a molecule, then acetone react with 1,2-diol which are in cis manner. If they are in trans manner, then in that case also acetone react, but the reaction rate is very low. If the 1,2-diol, or in case of 1,3-diol, if the diol are in cis manner, then in case of 1,2-diol, acetone react to protect 1,2-diol. In case of 1,3-diol, benzaldehyde react to protect that 1,3-diol. In cis case, reaction are faster. In trans case, reaction will happen, but the rate is very low. So yeah, one point is done. Means glucose when react with acetone, the diol presence is in 1,2 positions, that will react with acetone. So if there is more than one hydroxyl group, we use acetone to protect 1,2-diol functionality. Now see, now I am going to tell you one sentence. Please keep in mind, or please write down in your copy, that when theoretically we see many things in books, in books, we can see anything, but practically in laboratory, during the when we set any reactions, when we are performing any reactions, then something different will happen. So एक्सपेक्टेड प्रोडक्ट हम लोगों को नहीं मिलता है. जब हम लोग प्रैक्टिकली कोई लैब में रिएक्शन सेट करते हैं, सो उस टाइम पे थोड़ा अलग ऐसा कुछ देखने को मिलता है. तब हम लोग सोचते हैं जो पहले वाला मैकेनिज्म, जो पहले वाला रिएजेंट का यूज हम लोग पढ़ चुके हैं बुक्स में, सो 100% अकॉर्डिंग टू दैट मैकेनिज्म, अकॉर्डिंग टू द यूज ऑफ रिएजेंट्स, ऐसा 100% रिएक्शन प्रैक्टिकली नहीं होता है, कुछ डिफरेंट देखने को मिलता है. सो नाउ जो बात मैं बोलने जा रहा हूं वो प्लीज ध्यान से सुनिएगा. इफ वी आर परफॉर्मिंग any reactions taking a reactant, this is a reactant starting material, and we can say these are the reagents. This is a reactant material, this is also reactant material, but we can say these are reagents. So this is reactant material, these are also reactant material. So if we are performing any reactions taking a reactant, if we are using a reagent, so that reagent prefer the path in which path that reagent can be maximum used up by that reactions. I think समझ में नहीं आया. अगर हम लोग कोई रिएक्शन लैबोरेटरी में परफॉर्म कर रहे हैं, तो उस टाइम पे क्या होता है, जो रिएक्टेंट हम कंसिडर करते हैं एक रिएक्शन के लिए, बाकी एक दो और मोर देन 2 रिएजेंट्स हम लोग यूज करते हैं। सो एक रिएजेंट एक पार्टिकुलर पाथ रिएक्शन जो प्रोसीड होता है, सो देयर आर सो मेनी पाथ, जो पाथ का एनर्जी कम होता है वही पाथ ये फॉलो करता है। सो रिएक्टेंट कोई भी रिएजेंट्स, so there are so many reagents in the reaction, 4 reagents, so one reagent, so a particular reagent proceed via that path in which path it can be maximum used. It follows that path during the reactions in which path the reagent itself maximum amount of its reagent can be used, means as much as maximum amount or maximum equivalent of reagent can be used up during these reactions, then it will follow that path. So let's discuss details, then I think you will understand what I am trying to say. See the structure. So we already told that that acetone react with 1,2-diol which are in cis fashions. So see, we have to consider this 4 cyclic form. Obviously concentration of this cyclic form in equilibrium is 99%, these are less than 1%. So see, if we consider this type of structure, see this is alpha D glucopyranoside, one way is carbon 1, this is one way is carbon 2, so these are 1,2-diol in cis manner. See, in this structure there are no hydroxyl group except this 1,2, there are no hydroxyl group which are in 1,2 position and cis manner. This 2, 3 also 1,2 but trans. This 3, 4 hydroxyl also 1,2-diol but in trans fashions. See the beta anomer. This OH and this OH 1,2 positions but still they are trans. This OH and this OH 1,2 position but still trans. This OH and this OH are 1,2 position but trans orientation. So only alpha D glucopyranoside there are only one equivalent, you can say one equivalent of 1,2-diol in cis manner. This is a 1,2-diol functionality with this functionality acetone can react. So we can say ये वाला जो एनोमर है इसमें वन इक्विवेलेंट 1,2-diol प्रेजेंट है which is cis in manner. So cis fashion में 1,2-diol one equivalent means this 1 and 2 कार्बन में 2 हाइड्रोक्सिल ग्रुप cis fashion में है, so we can say one equivalent of 1,2-diol इसमें प्रेजेंट है. बीटा एनोमर में 1,2-diol cis fashion में 1,2-diol cis fashion में नहीं है, तो इसमें 1,2-diol प्रेजेंट है बट cis fashion में प्रेजेंट नहीं है. So in this anomeric structure there is zero equivalent of 1,2-diol present in cis fashion. Now see this very less proportional, very less amount of cyclic form. Let's consider this two form. See, in this furanose form, one ways and this is one ways, so 1,2-diol cis manner. This OH 2 and 3 1,2-diol trans fashions. Now see, this OH and this OH are cis in fashion. So in this case there are two equivalent of 1,2-diol which are in cis fashions. In this case, see, OH 1,2 but trans, OH 1,2 but trans, this OH cis and 1,2-diol. So out of these four anomeric cyclic structure, beta D glucopyranose, there is no 1,2-diol which are in cis fashions. Beta D glucofuranose, there is only one equivalent of 1,2-diol which are in cis in fashions. In alpha D glucopyranose, only one equivalent of 1,2-diol which are in cis fashions. Only in alpha D glucofuranose there are two equivalent of 1,2-diol which are in cis fashions. So जो मैंने मेंशन किया था, अगर कोई भी रिएजेंट हम लोग यूज करते हैं तो वो रिएजेंट ऐसा पाथ फॉलो करेगा रिएक्शन for proceeding reaction, so that reagent can be used up maximum amount. So if acetone react with this form alpha D glucopyranose, then only one equivalent of acetone can react, because here only one equivalent of 1,2-diol which are in cis fashions present. In this case acetone cannot react, only trans 1,2-diol present. So for reaction with acetone, the diol should be present in cis manner. If this acetone react with this anomeric form, 5-member anomeric form beta anomer, then also one equivalent of acetone react with this anomer. But if acetone react with this anomeric form alpha D glucofuranose, then two equivalent of acetone will react to form a bis ketal, means after reaction when 1,2-diol react with acetone, then ketal form, in this case bis ketal form. So मैंने जो मेंशन किया, अगर हम कोई रिएजेंट यूज करते हैं कोई रिएक्शन में, वो रिएजेंट ऐसा पाथ को फॉलो करेगा जिस पाथ में वो मैक्सिमम यूज हो सकता है, वो रिएजेंट मैक्सिमम यूज अप हो सकता है. सो दो in the equilibrium concentration 99% proportions of this present of this anomeric form, and less than 1% proportion is present in this two form. Still among these four anomeric form, the proportion of this alpha D glucopyranose is very low, very low. Still, since in only this structure there is presence of two equivalent of 1,2-diol, so when acetone react with this anomeric form, then two equivalent of acetone used up. So acetone react with acetone by this form, not this other three form, because acetone अगर इसके साथ रिएक्ट करेगा इस फॉर्म के साथ, so then acetone maximum used up होगा if acetone react via this form. So this is the chemistry behind these questions. So many of you think that yeah, 99% proportions are this 6-member ring, that is pyranose. So it should be, or it will react with this pyranose form, but this is not the actual case. So in presence of excess acetone, it will react only this 5-member ring, only the alpha anomer of the 5-member furanose ring, not the others. Because the reason is that if acetone react with this form, then acetone can be used up maximum amount. In this case, two equivalent of acetone used up, but only in this case and in this case only one equivalent or acetone used up. In this case there is no cis 1,2-diol, then acetone cannot react with this form. So out of these four anomeric form, the concentration of this form is very low, still acetone react with this form to form a bis ketal. I think guys आप लोगों ने समझ गया जो मैंने आप लोगों को समझाने का कोशिश किया. बट इफ स्टिल देयर इज एनी डाउट, प्लीज कमेंट करिएगा कमेंट बॉक्स में कहाँ पे डाउट है. और एक वीडियो हम लोग पहले बना चुका है रिगार्डिंग ओनली दिस क्वेश्चंस, प्लीज सी द वीडियो. नाउ सी द क्वेश्चंस. सो Yeah, I draw the simple form, not the this kind of form. So simple form means I am again telling you that this is not a CH2 group. So 1 2 3 4 5 alpha. See this alpha D glucofuranose will this form will react with acetone to form a bis ketal. 1 2 diol cis fashions एंड 5 6 कार्बन में जो डायॉल है वो भी cis फैशन में है. सो एसीटोन इसके साथ रिएक्ट करके एक बिस कीटल फॉर्म करेगा. नाउ दिस स्ट्रक्चर वी कैन ड्रॉ like this is a simple drawing in Fisher drawing, and this is this structure we can draw like that. So this OH right side mean this is anomeric carbon. This OH right side mean OH should be below, OH right side means should be below, OH left side means OH up, and this we can draw this structure like that. Now this structure correspond to this structure, and this structure also correspond to this structure. So in presence of XH acetone, glucose react via its furanose form. Although the concentration in equilibrium condition, the concentration of the furanose form are very less, still in presence of XH acetone, glucose react via the furanose form. I hope you guys understand. जो अभी तक जो मैंने बोला वो आप लोग समझा, ये मैं एज्यूम करके प्रोसीड कर रहा हूँ. सो लेट्स सी. सो इन प्रेजेंस ऑफ एक्सेस एसीटोन, ग्लूकोज डी ग्लूकोज react via alpha D glucofuranose form to form this bis ketal. So since there are two ketal functionality, that's why it's called bis ketal. Now ये वाला क्वेश्चन पूछा गया था गेट में. सो गेट में जस्ट ये वाला क्वेश्चन पूछा गया था, अल्फा डी ग्लूकोज एसीटोन एक्सचेंज H प्लस, कौन सा आंसर होगा. सो मैक्सिमम आई थिंक मोर देन 80% स्टूडेंट ये गलत करा उस टाइम पे. मैक्सिमम लोगों ने आंसर किया जिसमें 6 मेंबर रिंग है, बट कोई शायद लेस देन 15% लोग आंसर कर पाया सही, जो 5 मेंबर को सही आंसर किया. सो नाउ सी द स्ट्रक्चर 5 member ring. So these are Cs, these are Cs. This see, this should be Cs. This carbon should be Cs, and one OH, that OH, this OH upper means above the plane, this OH should be free, and this OH on rival react with acetone to form the correct answer should be B. In the answer D, see on in the option D, see they showed this OH group free and this OH react, means the free OH group, the above the plane OH group should be free. So the correct answer of that questions B. So maximum student उस टाइम पे ये क्वेश्चन गलत कर लिया था. So I hope after this seeing this video you will not mistake any thing regarding this type of questions. So वो क्वेश्चन जो था उसका आंसर ऑप्शन बी था. हम लोगों ने मैकेनिज्म के थ्रू देखा, अगर ये वाला रिएक्ट करके इसके साथ तो ये OH ब्लॉक होगा, 1 2 ब्लॉक होगा ऑन कीटल, एंड 5 6 में जो OH ग्रुप है वो भी ब्लॉक होगा. जो 1 2 3 में जो OH है वो फिर आएगा. दिस इज 1 2 3 OH ओपन रहेगा, फिर आएगा 4 5 6. सी द ऑप्शंस. इन बी ऑप्शंस 1 2 ब्लॉक, 3 फ्री, 4 5 6 ब्लॉक. इन द ऑप्शन डी 1 2 3 के साथ उन लोगों ने रिएक्शन दिखाया. सो ये आंसर सही नहीं है. सो आंसर बी इज द करेक्ट आंसर. नाउ लेट्स सी आवर modified questions. So in presence of excess acetone, the glucose via its furanose form react with acetone to form a bis ketal. Now we are using sodium hydride and benzene. So in this whole structure, see, normally कार्बोहाइड्रेट में बहुत सारा ऑक्सीजन हाइड्रोक्सिल ग्रुप प्रेजेंट होता है. नॉर्मली कोई भी कार्बोहाइड्रेट हम लोग जब कोई ड्रग बनाते हैं लैब में, सो मैक्सिमम ड्रग में कार्बोहाइड्रेट मोइटीज और एमिनो एसिड मोइटीज प्रेजेंट होता है. सो जो लोग नेचुरल प्रोडक्ट सिंथेसिस करते हैं, उन लोग कार्बोहाइड्रेट रिलेटेड काम करते हैं, उन लोग ऐसा ऐसा रिएक्शन प्रोडक्शन डिप्रोडक्शन हमेशा करना पड़ता है, क्योंकि there are so many OH group in a glucose or fructose or carbohydrate moieties. That's why to react with a particular OH group to modifying a particular OH group, they have to block other OH group. That's why in carbohydrate we are normally we used to block 1,2-diol with ketone. So हम लोगों को ये मिला 20 कीटल after reacting with acetone. Now sodium hydride and benzene. See, in this whole structure only the OH group at position 3 is free. Now it will become deprotonate. And second, we are using carbon disulfide. We all know carbon disulfide कैसे react करता है. So this anion will attack this carbon and it will form like this, and again this S minus attacks CH3I. So that iodide lives as a living group. So we will get this kind of product. Now we are using N-butyl strontium hydride. So this is the radical reactions we all know. So this is the mechanism of these reactions. Now if we use this reagents in this reactant, then this bond will break, homolytic cleavage, and hydrogen, this whole group leaves and on hydrogen will be attached in this C3 positions. So this is the mechanism. So just I assume this is whole as a R. So RO, AIBN is the radical initiator and this is a hydride donor. So now it will react with like this. First this bond, this S double bond, this C double bond S, one bond break, dot should be here, one dot, and one dot should be here, mean one double bond. Among the double bond, one bond will break, one radical should be sulfur, one radical should be carbon atom. So and now this SnBu3, this SnBu3 is, so attack this SnBu3 is, so reacting with this AIBN, SnBu3 dot will form, SnBu3 dot will attach this sulfur dot like that, and this dot break this dot, this radical broke into these fashions to release a alkyl radical, means this whole radical. In this case a radical will form. Now this radical will abstract hydride from another equivalent of tributylstrontium hydride, and RH will form, means this whole part we are assuming R, here one hydrogen will attach, and again this SnBu3 take part in the another cycle. In this way this cyclization of the reactions will continue. So this is a normal reaction. We all know that this kind of radical reaction how it will form. Now we will get hydrogen here. Now if we use aqueous HCl, now this ketal functionality will deprotect. So we will get this kind of moieties, mean only in first case in these three positions one OH group there. Now there is no OH group, only hydrogen. So there is no meaning of hydrogen showing above the plane. There are two hydrogen, so one hydrogen should be below, one hydrogen should be above. There is no meaning particularly for showing this hydrogen above. So it is now 3-deoxy, means in three positions no hydroxyl group is there. That's why 3-deoxy alpha D glucofuranose. We can draw like this. This is glucose. This is the mother acyclic form glucose. Just 1, 2, 3 positions. There is no hydroxyl group. So we perform these reactions just to exclude the OH group from these three positions. So we will get at last 3-deoxy alpha D glucofuranose. So A reaction, A using of 2, 3 and 4 reagent is very simple, we all know, बट दिस रिएजन ऑन हाउ कैसे ग्लूकोज के साथ इन प्रेजेंस ऑफ एसीटोन एसिटोन रिएक्ट करता है, वो मेन फंडा था ये वाला क्वेश्चन का। हम लोगों ने देखा जो डी ग्लूकोज कैसे एसिटोन के साथ रिएक्ट करता है। सो out of the 4 form, the less than 1% present in the equilibrium condition, still this alpha D glucopyranose, this form will react with acetone to form a bis ketal. Now this bis ketal react with this kind of reagent to just exclude the OH group from the 3 positions to form a 3-deoxy alpha D glucofuranose. So I hope you guys understood the concept behind these questions. So yeah, that's for all today. So one point I want to mention you that these questions already asked in just recent CSIR-NET 2021 exam. This question was asked in NET exam. So same questions, just normally मैंने जस्ट बिफोर स्टार्टिंग द वीडियो मैंने आप लोगों को बोला कि बेंजाइलडेहाइड हम लोग यूज करते हैं 1,3-डाइवल OH को प्रोटेक्ट करने के लिए, एंड एसीटोन यूज करते हैं 1,2-डाइवल OH को प्रोटेक्ट करने के लिए। सो जस्ट लास्ट CSIR नेट एग्जाम में ये वाला क्वेश्चन पूछा गया था, और मुझे लगता है मैक्सिमम स्टूडेंट ये क्वेश्चन गलत किया था। सो ये क्वेश्चन का एक वीडियो मैंने अलग से अपलोड कर दिया, जस्ट टेकिंग दिस क्वेश्चंस, एंड वी ऑलरेडी डिस्कस आल्सो दिस क्वेश्चंस टेकिंग द एनोमेरिक फॉर्म ऑफ ग्लूकोज नॉर्मली उन लोगों ने CSIR नेट एग्जाम में जस्ट मॉडिफाई कर दिया, बट एक्चुअली प्रैक्टिकल लैबोरेटरी में हम लोग सॉरी गाइस हम लोग कार्बोहाइड्रेट के साथ रिएक्ट करने के लिए ये बेंजाइलडेहाइड यूज करते हैं, जस्ट टू प्रोटेक्ट अ पर्टिकुलर 1,3-डाइवल टू रिएक्ट टू गिव अ चांस अनदर OH group. That's why only for maximum case में carbohydrate में we all know that there are so many hydroxyl group. So to protect the 1,3-डाइवल we are using normally बेंजाइलडेहाइड इन कार्बोहाइड्रेट केस में, बट जस्ट उन लोगों ने स्ट्रक्चर चेंज कर दिया, बट सेम कॉन्सेप्ट इसमें अप्लाई होगा। ये वाला क्वेश्चन डिटेल में हम लोग पहले डिस्कस कर चुका है। ये वाला क्वेश्चन मीन्स ओनली टेकिंग दिस compound or this compound and treated with benzaldehyde, what will be the product? Now in our upcoming video we will discussing these questions. So we already discussed using of benzaldehyde in presence of this compound. So how benzaldehyde will react with this compound or this compound. So we already discussed. Now in our upcoming videos we will be discussing we will discuss the modified questions, mean just we added 2 extra reagent to see what are the products or what will be the products. So please stay tuned, and regarding this video you already if you want to see, please see the video. We already discussed details about this questions. So in our upcoming video we will see the extra reagent we are added then. So in our upcoming video we will see details about these reactions. So maybe इस type of question upcoming कोई भी competitive exam में वो लोग पूछ सकते हैं. So please stay tuned. Thank you guys, thank you for watching and thank you for your support. So I hope ये वीडियो आप लोगों के लिए बहुत हेल्पफुल रहेगा, and please subscribe and like our channel. So Yeah, that's all for today. Stay safe, stay healthy. Okay, thank you again. Bye.